Hi everyone, welcome to another episode of Tiny Experiments. So in this Tiny Experiments we're going to be looking at a particular application that I've put together with the aid of various coding support techniques that I sort of use. And it got a bit meta in the process of putting this together. I ended up putting together a program which helps you review code, analyze code, refactor code in interesting ways that hopefully will help with your practice of writing code. So incredibly meta. And before I go through the program and just talk a little bit about, some of the experiments you can do here and things you can sort of tweak and tweeze, I'll just explain how this all sort of really started off. So as I've mentioned before in various episodes, I've become very enamored, very impressed, or whatever, I'm trying to think of a good word to describe this, very motivated by a book called Tiny Habits by BJ Fogg. And in the book early on, it starts off with this habit called the Maui habit. And the Maui habit is very simple. So when you wake up in the morning and put your feet on the ground, you say to yourself, today is going to be a great day, and then celebrate the first achievement of the day with a smile. Now, so after you've said, today is going to be a great day. So I thought, well, I'm going to slightly change that. So I use a phrase, today is going to be a flourishing day, and then smile. But what then happens is I chain it, because one of the things you learn through both Tiny Experiments and Tiny Habits, so I find those two books are really good, really complement one another, is that it's good to get in a sort of achievement early on in the day. And so immediately the first thing I do before I do anything more is try and think of something flourishing, like a small win that I can do that in effect proves to me that yes, indeed, today is a flourishing day. And how I've started doing that is leveraging LLMs to come up with an interesting, simple experiment or something that sets me up for the day. And the achievement in that flourishing is having a plan, if you like, something that I can work on. And that in and of itself has been really helpful, because once I have that plan, and the plan is sufficiently small, it doesn't matter too much if the plan doesn't go according to plan. But what matters is that it gives me something engaging, and that act of engagement is flourishing. So it works really well on multiple levels. So the other day I had done a similar thing where I sort of got up, did my, today is going to be a flourishing day, smiled, picked up my iPad and started to riff around a few ideas in my head, in multiple LLMs, around techniques I could use to engage me with code, because it's really difficult at the moment. It is very tempting to totally lean into LLMs to do coding, and in doing that I found you sort of lose something. So I thought, well, why don't I come up with some sort of program which allows me to retain that engagement? So I thought, well, a code reviewer would be a great way of doing that. And initially I sort of went down one avenue of just doing a code review program. But then, because I thought, well, I could do a command line one where, you just type in the name of the code file that you're trying to evaluate, and then it just spits something out. But then I thought, well, there's a whole load of other things that I do around coding which I find super helpful. And so I started to put together this list of things. So I thought, well, yeah, code review needs to go in there. Some sort of refactoring really appealed to me. So this is the idea of taking some code, thinking about the different paradigms that code could potentially be expressed in. So, if you're working in Python, you could go down an OOP, object-oriented programming route. You could go down a functional programming route. But I thought, well, why don't I leverage, in this case, Google Gemini, to just come up with some other paradigms that might be in the language that I'm not necessarily aware of, or have missed the subtleties of. And then I thought of, well, obviously somewhere in there, I'd need some sort of analysis would be nice, like a beginner-friendly analysis where you, with the code, you sort of tells you what the code does. And then later on, so I'd done all that and was, super comfortable, if you like. Oh, no, not super. I felt a supreme sense of flourishing in what I'd done at that point, and I'd already fed in some pre-existing base code that I've used in previous videos, I think, and also decided to go down a bit of a sort of if we go up to the top, you can probably see we've got a lot going on. Down a class, creating a class called Code Riffactor, and going down that particular avenue. So we've got lots of references to self here as well. And then to sort of finish it off, I thought, well, why don't I just at that point say to the particular LLM that I'd gone down at that point. So I think I'd sort of switched around a little bit and jumped around between different online large language models, from Gemini to Claude, and then I think I ended up in DeepSeek, and I had it sort of in deep thinking mode with searching on, and then I just said, oh, here's a list of things I wanted. I'd already done it, and I'd already given it the list, and it had already to some degree interactively vibe coded the stuff. And then I just said, oh, come up with some other ideas that play with this. So it came up with a quick summary idea and generate documentation. And I think suggest improvements. But then it did this interesting thing where it just decided to have this ability to switch between different output preferences, either screen, save to file, or both. Because I'd already mentioned about, I wanted to save it to MD. And then I also had mentioned that I wanted it, the very first thing it did was to choose the file that you were going to do all of this on. So, there's obviously the ability to load a different file in. So that was interesting, seeing where it took that. And, tweaked and tweezed a little bit some of the prompts that it had come up with. So you can see here, all of these are self-contained functions where each of the analysis, or the thing you're going to perform on the code, this code refactoring, which was a portmanteau of, I was thinking, well, I'm now getting to the realms of stuff where it's not strictly speaking, it's a strange area, because it's obviously AI assisted code. It's not full-blown vibe coding. There's lots of instructional or learning based interventions going on here. So it's like I'm sort of riffing around with code, riffing on a concept. So I wanted riff in there, and then I sort of thought, well, we're doing refactoring, so why not call it the code refactor? Or I suppose the code refactorer would be more correct. But anyway, code refactor is a little easier to say. So all of these are abstracted away in their own little thing. We've got some stuff to do with the main program loop as well, and the usual sort of Python idiomatic while leaning into object-oriented programming and classes as well. So the other thing I did was I just got one LLM. I can't remember which one it was. It was probably DeepSeek, because I hadn't played around with that for a while, and just got it to create a test piece of test code to work on. So let's just run this code Riffactor and see what happens. So the first thing it's going to do is ask you to enter path through file codes. So this is very quick and dirty, by the way. I'm releasing this fairly early on in development. Again, surprise, surprise, it's not production code by any stretch of the imagination, but I just wanted it out there because as I used it, it sort of went down some interesting avenues. So here we go. So the first one is very simple, and I actually wanted that in there as well, which is just a simple identify the programming language. Obviously stuff like this is going to be fairly easy to identify. Python, so we just maybe most of the time you could just tell it what it is, but I thought that was just a fun little feature to have in there, particularly with more obscure languages. So you could take like an unknown chunk of code as well with this, as it only deals with a single file. So yeah, that's the main thing. So it's probably not so good for huge swathes of code like multi-module, but it's nice if you've got like a single section of code that you just want to riff around with and start to pull apart and use for various things. So we're going to do so here what it does, it always waits with whatever's on the screen. At the moment our current output preference is to file. So let's pick one where we're actually doing something interesting. So we're going to do a code review, and it's still working on that same section of code. So you can see here, if we want to load a different file, we have to go to option 9 to do that. But we'll stay working on this one. So we go perform a code review, and then as you can see, I've been running this before, but what it does is for each of these it puts it into its own little MD file. So we're going to do a code review. Now at the moment our output preference is to file, which is the default. I can go into option 8 and we'll see in a moment what's in there, and then switch between either output to file, output to screen, or output to both file and screen. So the code review is probably going to take a little bit of time to do that, and you can see we've got beginner friendly analysis, Riffactor for different paradigms, suggest improvements. So there, it's done it. So if we actually look at the test review, I won't look at all of these, so you can see here it just depends the name of the file and then what you're doing. So we're doing a review, and let's just do that. So that's our code review for test. So it goes through a number of different things. Now what you'll notice here, I've got it set so that it doesn't append. So you don't, if you accidentally run the same, run against the same code twice, you don't lose the original one. It just appends it to the MD file. So you can see there, and it's quite interesting to see when if you do run this multiple times, whether it comes to the same conclusions. And that then going with that, there's various ways you can experiment with this code. So you could go through and you could find the error in this code for the particular function where it's abstracted, and play around with the prompt if you wanted to. So you just go to the appropriate part and sort of modify that particular prompt in there. Now you can see everything's pretty straightforward, And of course quite a lot of this could be further refactored to remove some degree of redundancy, and you could abstract away chunks of this maybe to helper functions. Would be another way to experiment with this. But what you'll notice is there's a number of functions here beyond just the prompting one. So we've got the setup function here, which is grabbing that Gemini API key. So because I'm using Gemini, I need an API key, and on my system I save it as an environment variable. And it actually tests the connection as well early on when it's setting up, just to make sure everything's fine there. There's no problem. It just says hello to it. We've got an output preference here, console both or file. There's our handling of output. There's our file loading. There's our language identification. And you can see what's happening here is we're actually just using the generate content method from the Gemini library to do this. So we're using that library to largely abstract away a lot of the what we would normally do through requests in here. So I have abstracted that away, so there's not much experimentation you can do on the request sides of things, because we're leaning quite heavily into doing it this way to getting the response. And you can see we are just literally passing a prompt. There's no in here, there's no other sort of the sort of tweaking you've seen me do before in these episodes when I've been dealing with API requests around things like Google grounding, that sort of stuff. It is minimal here. So it's interesting to see what happens when you do it this way. Now, obviously, in the future, I would want to modify this around a little bit and start playing around more with temperature and other things as well. But as a sort of first pass wrapper, it was really just seeing what comes out in the raw form from Google Gemini, sort of as is, just using the Gen AI library to control all that sort of interaction. So we could wrap up some of this stuff, this generation, in its own little helper prompt, where we can tweak those other settings if we wanted to do. So that's another sort of experimental avenue you can go down there. So what else have we got here? We've got a beginner-friendly analysis, so we can run that. And again, it's working on the same thing, working on that same file, because we haven't changed that. And if we go down and look at the beginner-friendly, let's try and, because our code reviews, this should be in order. Yeah, here we go. Provide a step-by-step explanation of what the following self.language code does. The explanation should be suitable for a beginner programmer. Break down complex concepts and explain them in simple terms. Use analogies where helpful. Format your response in Markdown with appropriate headings. So that's now appended to our test beginners guide. And if we do this, you can sort of see here what's going on here. So we could probably get a bit meta and actually point the code Riffactor.py back on itself, I suppose, and get to do a bit of self-analysis. But yeah, it's pretty interesting with all of this breaking down here. The other interesting thing with this is, if you pick a file of a fairly obscure programming language, it's a pretty good way of test driving the ability of a large language model, in this case Google Gemini, to just work within what it's been trained on and not reach outside of itself through grounding or anything like that. Now by default, Google Gemini now has thinking switched on as well, so yeah, it is doing some thinking, but everything is within the confines of the large language model and how it was trained originally. So at some point in the future, no doubt, I'm going to experiment with some slightly more obscure languages and see what happens. And then at that point, I will probably start to think about adding in some grounding stuff like that. I've been thinking a lot recently, actually, about how to do sort of on the fly. I'm trying to think what it's called now. Is it called meta training? Anyway, there's some techniques you can use to literally adjust models just before you run them, in terms of doing several shot prompts, which are sort of wrapped up in a JSON file, and it's something I only sort of stumbled across last night, that particular aspect of it. I mean, I was aware of, say, several shot tricks in prompting before, but not where you're sort of wrapping it up in a preformed JSON file and then feeding it into the model when the model starts, and then you sort of all the requests you do subsequently after that are shaped by that initial set of prompts. So that's something I want to play with actually today at some point, and hopefully I'll have some tiny experiments to share as a result of that. So then we move on to what we just did beginner friendly analysis. Riffactor for this was interesting actually. This was one of the ideas, probably out of all of them, that I was most looking forward to seeing what happened. So we'll refactor for different paradigms. Again, we haven't changed anything yet. When I upload this to my GitHub page, I will not only include the KIF code Riffactor .py file, but I'll include this test file as well, so you don't even have to create your own Python file to experiment with it if you want to. Now, the usual things here need to be installed, so you need Python installed, you need an API key, you need some sort of IDE to experiment with and build this, or sorry, to run it at the very least. But I'll include links to all the resources. So refactor for paradigms. For the programming language, identify the various programming paradigms it supports, then refactor the following code to demonstrate different paradigms and the idioms in. For each paradigm, name the paradigm, briefly explain its characteristics, provide the refactored code using the paradigm, explains the changes made, format your response in Markdown with appropriate headings. Now we're leaving it up to the request or the response and the LLM to decide like how far down the rabbit hole it goes with the paradigms that the language is capable of. So it's going to be interesting to see. Now again, this will be run at least one previous time, so we should have the sort of accrued results in here. So let's have a look. Test paradigm refactor. There we go. So let's see what it's picked up on. So this was the one I did originally, and it said object-oriented, imperative, procedural, functional, aspect-oriented, and declarative. Now some of those paradigms sort of cross over and are sort of wider top-level descriptions of a group of paradigms that when you go down the sort of paradigm tree, if you like, you'll get to the more granular ones. So it picked up on three that it went with, which I don't know if you saw there, the sort of full-on OOP, it declared that the original code was primarily written in a object-oriented imperative stroke procedural style. So it was refactored to highlight OOP enhancements. So lean a bit more into object-oriented programming. And then it said what it modified. Functional programming. So you can see at this point, it looks like we've lost the classes as a consequence. And then aspect-oriented programming via decorators. So the thing with this is you would want to go through and start to pull it apart. And, you know, again, you can get a bit meta with this because you can start to pull these out, resave them as new files, and then run them through, you know, the explainer program. So it's really fascinating how this sort of loops back on itself, and you can, again, the reason for calling this refactoring, you know, sort of like riffing around with all sorts of ideas and going down a ton of rabbit holes. And you know how much, if you've been a long-term friend of the channel, I know I like rabbit holes on this channel. We've got a conclusion. So then this is the second bite, if you like. So it goes back through. Let's see what it does this time on a different day. So it's picked up OOP. Is that the only thing? Imperative programming. Yeah, so on different days it's going to lean into different things, I imagine. And again, you can play around if you want to play around with temperatures and top P's and top K values. You can modify the program to do that, so you might be able to get it a little bit more consistent in what it's doing. Functional programming lens, declarative programming lens, that sort of stuff. So yeah, interesting thing to play around with. So moving on here, let me what's happened now? I've got bringing a friend in lesson twice. Weird. I should check that. Might be a bug there. Oh, press enter to continue. Oh, there we go. It was just an anomaly on the screen. Suggest improvements. There we go. I'm going to just double check the code because I took something out. That we had there was some duplication in here in one of the versions. I don't think it's still here. But while that's running, we'll just check. We're good. Yeah, must have just been a screen anomaly when I sort of redid the size of this bit here. So generating improvement suggestions. So let's go and just have a quick look at that. Suggest improvements. Suggest improvements. Readability and maintainability, performance optimizations, modern language features that could be applied. That's an interesting one to ask about. Error handling improvements, code structure and organization. Provide both recommendations and refactored code examples. This is quite a good one to modify, actually, because you might want to add security considerations as an option in there. That would be a good one to add. So, there's our improvements. Okay, and we will do that. Suggest improvements for test. Readability, performance. So this was the one I ran the other day. Then there's some refactoring suggestions there. Cool. Interesting. I need to clean this up a bit. We've got a bit of we have a little bit of MD weirdness going on here. I might just review that at some point before I upload it. Didn't notice that before. In that it's sticking all of this in a code section. It's probably due to I'll double check that before I upload it. See what might be going on there. It's possible that where it's using it's delineating using the symbols to indicate chunks of code might be being misapplied there. Something weird going on here. Looks like when it appended the two together. I need to have a check there. Yeah, there's probably like an open one of these maybe by the looks of things. So there might be some stuff that was generated by the some of these that were generated by the response might be conflicting with what the program is putting in there to delineate certain sections. So I'll double check. That's not the first time that's actually happened. So moving on, we will do generate documentation. This press enter to continue is here because when you're printing to the screen, it's quite handy to have it hold on the screen before you get the menu back up again. So let's see what it does for this. And we will go down to the generate documentation. So all these are pretty straightforward. They're multi-line prompts, but nothing over, 4 to 5, around that amount of stuff to do. So you have to include overview of what the code does, function, method, documentation with parameters and return values, usage examples if applicable, and any dependencies or requirements. Format your response in Markdown with appropriate headings. Test documentation. Here's one I did earlier. You can see here we've got some expected output stuff as well. How to, direct usage stuff. Dependencies or requirements. Cool. Yeah, it looks like there's something that you can see. There's something a bit weird going on here with the code. So I need to check here. I've got some appending considerations to do. My suspicions are that there's something going on wrong down here. I need to close off this a little bit better, so I'll fix that before I upload it. Shows you how fresh off the press this is, and why it's always useful if you're doing appending stuff to an MD file. You just make sure the previous save has closed off correctly or finished off the MD, because then it can spill over into the appended information. And there's ways you can modify this program to maybe handle that better. So you could actually get it to date stamp each of these, so it actually produces standalone MD files all on its own. I decided I wanted it this way so I could sort of stack them into a single file. If I was doing more than one test of the same program, so it was all in the same file together. but obviously I've hit a snag in doing that, so I need to do a little bit more clean up there before I upload it. And then also there's this quick summary thing. So this one just does give me a quick summary, limit the length, so focus on the main purpose and key functionality in 3 to 5 sentences, plus you're locking down the response that it's going to come back with. So it comes back with it, but it limits the what's up here, because it's assuming that it's only going to be 3 to 5 sentences, and you can play around with these values a little bit if you find it's truncating things. So yeah, that's it. It's a very quick summary. So no for that one it is console only. And then I mentioned, you've got this set output preferences there, and then you can choose save to file, print to console only, save to both files, and print to console. So if I say do that and I run something else, you can see here it's modified to say currently both, then it would do both. So if I was to rerun one of these options, like I don't know what the quickest one is really we've seen here. Let's do just this performer code review. So if we do that with this setting, which up here, if we go back up to performer code review, so we can actually see what that was. There we go. Code quality assessment, potential bugs or issues. So this one does do, this one does security vulnerabilities for the review. So that is in that one. That's the full-on code review. And so there you can see that's what's come back to the screen. This is handy for debugging if where I'm having problems where it's saving stuff to the MD file to find out which markup stuff is coming from the response itself and which markup problems are caused as a result of me introducing sort of code delimiters in the markup. So I'm going to have a look at that in a moment, see where things have been going wrong. So that displayed on the screen, but it's also going to add it into the particular code review one. So there's test review. Again, if this file was called something else, then it would actually create a different MD file for that. And so now we have another one added to the bottom. And if we go down all the way to the bottom, we should be able to check that that's indeed the same thing. Obviously you might want to do additional date stamping here as well. Now we're doing sort of appending to a file there. This one seems to be behaving itself. So I need to look at the other ones, find out where the problem might be. It looks like I'm getting a weird interaction between the MD that the response is coming out the response and my manual stuff definitely there. And then finally, you just can go back to that screen. So so we could point this at itself technically. It'd be interesting to do if I do something bizarre. So let's just point this towards, let's see if we can break this. I haven't tried this before doing this episode. So I'm going to actually try pointing this at an NMD file just to see what the hell's going to go on there. So it's done that, and I'm going to actually ask it to see if it can identify the programming language. It says Python. Probably can pick up the Python in there. And if I was to start to do this, it'd be interesting to see whether it teases out stuff in there or doesn't. And again, these are interesting experiments you can do to see how a model might respond to mixed inputs. So actually we could do a quick summary, couldn't we? So let's just try that and see what it actually says here. Okay, so it would, I'm assuming, which we ran the I did a programming language. I probably have to do, oh yeah, this, so it looked at the original test review.md. Is that what it's working on? I probably want to change this actually so it actually comes up and reminds you what file you're currently working on, in case you've forgotten. That would be a good feature to add in actually. So test review.md. So what was in test review? It was this one. Okay. Oh yeah, so it is pointed to bank account one. Oh, there's some code snippets there. I just wondered where it was working out that it was Python. But yeah, there's the code snippets. Interesting. So there we have it. Something else to have a bit of fun with and a bit of experimentation here with, and modify and add in your own features. Again, yeah, it's not production code ready by any stretch of the imagination, but fun things to play around with. Thanks once again for watching. Bye for now, and I will catch you in a future video.